We're live. All right, so here we go. Today's date is 10/16/18. All right, so this is all four of the parabolas that you guys did. They're all pretty close to being the same with some different tiny little things. First of all, if it is opens up or opens down, listen carefully. If it opens up or opens down, it's a function, right? It's a function. And since it's a function, it's got to be a y equals equation. So it's a y equals, this one, 1 over 4p x minus h squared plus k. The vertex is always at, going to be at hk, all right? Has to be. Now, the only difference between these two is the fact that you'd have a negative. So if I look at this poster here, you guys see it? It's got the negative. It's the only difference. It's a frowny face, so it's negative. It's not happy, okay? But it's still going to have its vertex at hk, okay? If I take a look at these two, they're sideways parabolas, okay? They're not functions, but they aren't going to be y equals because they're not functions. They're going to be x equals. See the difference? They're x equals equations, not y equals equations. And instead of hk here, the k is the y value of the vertex, so it goes kh. Okay, we're gonna do some of these, okay? So the vertex is still gonna be hk, but inside it goes kx. So the vertex of these things is still gonna be at hk, right? But in the formula, the h goes with the x, and the k goes with the y. Does that make sense? This is the exact same thing. The only difference is this is negative here. Let's see, where's that one? Sideways, backwards. Here it is. This one right here. So it goes backwards, sideways, negative there. It's the only difference, right? So let's take a look at, first of all, question number 3. So number 3, it's not quite in the form I want it to be in. It should say y equals, okay? So what I'm going to do in number 3 is first just fix. I'm going to solve for y, okay? So solve for y, I'm going to divide by -2, divide by -2, and I'm going to rewrite this as a y equals a x squared over -2, okay? So I want to graph this. So the vertex on this one is at 0, 0, okay? The vertex of this one is 0, 0. I could rewrite it like this, kind of a pain, but I will. I could rewrite it like a -1/2 parentheses x minus 0 squared plus 0. I mean, this is the exact same equation I have here, but that's kind of redundant. I don't really need the zeros. So I know the vertex is at 0, 0. So I'll go and put my dot at 0, 0. Okay, that's easy. Now, we've got these things called the directrix, and we've got these things called the focus. Actually, let's go here. So these things called the directrix and the focus. We need to find that. We know that in the formula that it should be 1 over 4p. Now watch carefully. In this case, 4p is equal to -2. 4p, this number is 4p. According to the formula, that should be 4p, right? So that means -2 is 4p, so p would equal, divide by 4, -2 fourths, or p is equal to -1/2, okay? So now I know p. P is the distance from the vertex to the focus, and is the distance from the vertex to the directrix. Because this is negative, it's going to be a frowny, right? It's going to be this one right here, okay? It's that one right there. So what I'm going to do is, I know p is -1/2, so I'm going to go ahead and put my directrix in. This is 2, 4, so it's really going to be here. And my focus is going to be here. Okay, so my focus is at the point 0, -1/2. My directrix is at y equals 1/2. Great question. Okay, one more time. So p is -1/2. Okay, and so p is the distance from the vertex to the directrix, or the distance from the vertex to the focus. Okay, does that make sense how I did that? Now, to graph this, the distance here is 4p, which is 1/2. Okay, the distance through the focus. So to graph this parabola, what I'm going to do is this. I know that it's got to be a total of 1/2, total of 2, 4p is 2, so it's got to be a total of 2, so I'm going to go here to 1 and here to 1, because a distance of a total of 2. So this distance here, and I'm going to write it on one of these posters. Okay, there it is, 4p, awesome. Who did this one? Nice. Okay, I'm going to circle this. So this distance here will always be 4p. Through the focus, the way you draw it, you get the vertex. You get your 2 points by going 2p, 2p. You can graph it in, okay? All right? Now, let's take a look at number 5. Did you want to do number 5? Yeah, I can do number 5. Okay, number 5. So, on number 5, I already know where the vertex is. The vertex of this one is at -1, -3. You okay with that? The opposite. Caleb, was that you who said the opposite this morning? No, it was Quinn. It was Quinn, right? Thank you, Quinn. It is the opposite inside, so we're going to go to -1. Let's go by 2, so -1. -3 is probably just about there, okay? Now, this number here is kind of tricky. It's a -2, okay? So we need -2 is equal to 1 over 4p, okay? Yes?
Okay, so when we first did it for the horizontal axis of symmetry on page 102,
Yeah.
you switched it so it would be HK. And now why isn't it?
It still is it's still HK. It really is. It's still HK.
Yeah.
And H is -1, but it's the opposite. Remember when Quinn said it's the opposite?
Yeah, I know. Yeah.
Okay. Andy, am I making sense?
Yeah.
Okay.
Okay.
If I made a mistake, let me know, okay? All right, so we go to 1, 3. So this one's a little bit tricky, but if I rewrite, let's see, I can rewrite without confusing everybody, okay? Y equals x plus 1 squared minus 3 over a -1/2. All right, this is going to confuse you. I don't know if I want you to know this yet. Let's not do this one. Let's not do this one, okay? All right, let's go on to 6, okay? Let's go on to 6. Let's skip that one. I don't want to do anything that hard. This is geometry, not algebra 2, right? Okay, here's number 6. What's the equation? Well, first of all, what is P? What's P? It's 5. How'd I get that?
Because the focus is at 5.
So P is 5, right? It's this picture here. Yes, Evelyn. Sure. It's this picture here, right? So I want to use this itsy bitsy equation down here, but it's there. So I want to write y equals 1 over 4p x. The vertex is at 0, 0, right? Minus 0 squared plus 0. Because the vertex is at 0, 0. Now I don't need the zeros, but I put them in there so you'd see the form, okay? P is 5, right? So this equation is y equals 1 over 20 x squared. All right, let's do 8, and then we're going to do some graphing, okay? Let's take a look at 8. So on 8, no, let's do 7, then we'll do 8. I changed my mind. Let's do 7. Okay? So first of all, here's how I tackle it. First thing I do is I look for P. What is P? P is 1. You guys agree?
Hold up.
It is 1.
No,
right?
the scale is whack.
1. Oh, it's 1/2. I agree with Landon.
Wait.
P is 1/2.
Why is the first unit so much longer than the rest?
Huh? Okay.
Oh, never mind.
So it's sideways, so it's an x equals. It's sideways. In fact, it's Morgan. Beautiful graph. You know the cool thing, Morgan, is you guys are so nice and big that we can see it. It's Morgan's graph. You guys see it's Morgan's graph? So here's Morgan's equation. Morgan's got an x equals 1 over 4p y minus k squared plus h, right? So we're going to go x equals 1 over 4 times 1/2 times a, vertex is at 0, 0, right? So go y minus 0 squared plus a 0, okay? Okay. So we know that, you're right, the scales are all goofy, Landon. It's 1/2, right? So my p is 1/2, so the equation is 1 over 4p. I put the 1/2 in for p. I know the vertex is at 0, 0. Now I'm going to fix this. It's really going to be x equals 1 over 2 y squared.
Wait, the vertex is 0, isn't it?
Yeah. Isn't it 0, 0?
No.
Yeah, x, y goes right
Oh,
through.
yeah, you're right.
Sometimes. Okay. All right, now, you've got graph paper, right?
Yeah.
So let's do this one first, okay? So let's graph this, okay? Let's graph on number, I'm going to do it on a piece of graph paper. Let's take and graph x equals 1/16 y minus 3 squared plus 1, okay? All right, let's graph this.
Wait.
Let's graph this, okay? So let's graph x equals 1 over 16 y minus 3 squared plus 1, okay? Now, it has to be Morgan's. It's Morgan's beautiful picture. How do I know it's Morgan's?
This is an X.
Look at it.
It's an x equals, and Morgan's opens up towards positive, doesn't it? Morgan's opens up towards positive infinity, and the one back there opens up towards negative infinity, right?
Yes.
So let's do the equation. So first of all, before I do anything, the
Why
vertex.
can't we use the blue one like that?
Yeah,
Yeah,
that one's
that
pretty
one's
good.
way better than ours.
Well, I like the blue one. It's hard to see because I don't see very well.
Yeah, Morgan's
Showing you
very
guys.
big.
I like the blue one. It's just hard for me to see because I have bad eyes. Yeah.
Yeah.
So now here we go. The vertex. Be careful. Where's the vertex? Be careful.
Vertex. What?
It's 1,
That was
3.
my question, because like.
Yes, it switches around if it's x equals, doesn't it? So here's the thing, Andy. Always remember
We
that
switched.
because of the y. See the y? Here's how you can always remember. You see the y? The y coordinate has to go with the y. The y coordinate, so let's write this out as 1, 3. Do you see the y coordinate went with the y, didn't it? The y coordinate with the y. So there's my vertex. What is p? What is p?
It was 1/16.
That's 4p. So 4p is 16.
Oh, so it's 4.
4, right?
It's 4.
You guys got it? Okay. So then if I'm going to graph this, grab a ruler, and I'm going to go ahead and try and put this in. So, all right, like that. So let's go to 1, 3. So 1, 3. There's my vertex, right? It opens out like the blue graph. We'll just, the blue graph or Morgan's graph. So I'm going to go from here. I'm going to go 1, 2, 3, 4. Okay? So I went 4p. That's my p. And I'm going to go back 1, 2, 3, 4. Okay? So if this is my vertex, then the distance from the vertex to the focus is p. And the distance from the vertex to the directrix is p. Now directrix is an invisible line. So I'm just going to draw my invisible line with my directrix. This. Okay? Now, 2 more points. This distance, everybody watching? This distance is 4p. Okay? This distance here is 4p. This distance is 4p. So 16, right? So I'm going to go up 8, down 8, and get 2 more points. Okay? I'm going to go up 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And then I can draw in my parabola just like that. Let's do one more of those, okay?
Oh, that's how that.
Let's do one more and then we'll call it good, okay? All right. Scoot this. All right. Everybody got that? Let's do one more, okay? Let's do a y equals negative 1/8 x plus 1 squared minus 2, okay? Write that down. We're going to go y equals a negative 1/8 x plus 1 squared minus 2, okay? Annie, I'm going to answer your question. So the vertex,
Yeah, since it's a line, it will be -1, -2.
-1, then -2, right? Because the x value of the coordinate has to go with the x. Perfect. That makes sense. And always, like Quinn said, it's always the opposite of the inside, right, Quinn?
That's right.
Totally right. Now, 4p is 8, right? So p is 2. Now, which picture is it? Which one up here is it? Which one is it? It's this one. You guys agree? It's this one here, okay? Because it's an x squared, and it's going down. Put the phones away. Phones away.
Put your phone away.
Okay, so then, let's see if we can graph this. And so let's go to -1, -2. It's my vertex. I'm going to go up 2, call that my directrix. I'm going to go down 2, 1, 2, call that my focus. Okay? I'm going down 2 because we know it's a frowny face, right? So it's going to go around the focus. This distance here is 4p, which is 8. Okay, this distance is going to be 4p, which is 8. So I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. So that my distance here, this distance here is 4p. Okay, this distance here is always 4p. So then I can just draw in my parabola, and there it is. Okay. How is that?
Doing great.